Take a slow, deep breath right now. In that moment, thousands of trillions of oxygen molecules rushed into your lungs, entered your bloodstream, and reached nearly every cell in your body. This unseen process powers billions of microscopic chemical reactions that keep you alive every second of every day. Without this gas, the human brain begins to shut down within minutes. This biological dependency extends to our entire physical world because every modern power plant, manufacturing center, and hospital operates on the same principles of chemical energy release. Human civilization ceases to function the moment the supply is removed. Roughly 21% of Earth's atmosphere is oxygen gas, but a much larger volume is hidden elsewhere. Nearly half the Earth's crust is composed of oxygen bonded within rocks and minerals, and oxygen accounts for 89%. To understand how this gas became so prevalent, we have to look back 4.5 billion years to an era long before dinosaurs or the first fish. The early atmosphere was a toxic mix of volcanic gases like carbon dioxide, methane, and ammonia. If you could stand on Earth back then, every breath would be deadly, as there was zero free oxygen in the air. The element most essential for our survival today was missing from the early planet, leaving the world a lifeless landscape defined by volcanic activity. The turning point began with cyanobacteria. These microscopic organisms developed photosynthesis, a process using sunlight to absorb carbon dioxide and water, producing sugar for food while releasing oxygen as a waste product. Initially, this oxygen reacted with iron in the oceans, forming massive iron deposits we mine today. It took millions of years of this process, the Great Oxygenation Event, for the gas to finally accumulate in the atmosphere. This ancient transformation now powers your 37 trillion cells. Every one of them functions as a miniature power station that requires a constant supply of energy to maintain your heartbeat and your thoughts. The nutrients you consume are chemically stable, meaning they do not release their energy spontaneously. Inside the mitochondria, oxygen acts as the reagent required to break these molecular bonds during cellular respiration. This produces ATP, the universal energy currency used by every living cell. Oxygen functions as the primary driver of this metabolic efficiency. It is the biological engine that allowed life to move past simple bacteria and evolve into the complex organisms we see today. While we associate oxygen with flames, the gas itself does not burn. Oxygen isn't a fuel. Instead, oxygen is an oxidizer. During combustion, it accepts electrons from fuels like wood or methane. This chemical exchange forces the fuel to rapidly release its stored energy. Without the presence of an oxidizer, a fire cannot exist regardless of the heat. Human industry is built on this specific reaction. In modern steel production, pure oxygen is injected into molten iron to remove impurities, a process that determines the strength and quality of the metal. This high-temperature reactivity also allows us to use modern welding torches to cut through heavy industrial steel with high precision. Outside of industry, oxygen is critical for medical survival. It supports safe anesthesia during surgery and serves as a primary treatment in emergency rooms when a patient's respiratory system fails. However, this same chemical reactivity also drives the slow destruction of the materials we build with. When iron is exposed to oxygen and moisture, it undergoes oxidation, forming rust. This process slowly weakens bridges, pipelines, and vehicles, costing the global economy hundreds of billions of dollars every year in corrosion damage. The exact chemical property that allows us to forge steel and sustain patience is the same force that returns metal to rust. We constructed our modern world using a reagent that is chemically bound to eventually dismantle it. Rockets face a specific challenge in the vacuum of space. Because there is no atmospheric oxygen to facilitate combustion, they must carry their entire supply from the ground. To fit enough oxygen inside a rocket, engineers cool the gas to minus 183 degrees Celsius. This turns it into a pale blue liquid, or LOX, which occupies 800 times less volume, ready to ignite with blinding thrust. When this liquid oxygen combines with fuel, the reaction releases the energy required to lift a vehicle weighing thousands of tons away from Earth's surface. To sustain a permanent human presence on the Moon or Mars, we cannot rely on bringing every tank of oxygen from Earth. NASA is currently testing in situ resource utilization, systems designed to manufacture oxygen directly on other planets. These technologies separate oxygen from the Martian carbon dioxide atmosphere or extract it from lunar minerals. This provides a local source of breathable air, drinking water, and the fuel needed for a return journey. Every breath you take connects you to the ancient bacterial processes that first shaped our atmosphere and the high-energy chemistry that now propels us toward other worlds. This element is the foundation of our biological history, our industrial capacity, and our eventual presence among the stars. The next time you breathe, remember the story you are inhaling.